So for number 1, 2, and 3, we need to determine whether or not we have a perpendicular bisector. And in order for it to be a perpendicular bisector, we need one, it has to be perpendicular to the line on the base of the triangle, and it has to be equidistant to the ends. So let's look at number 1. We're going to do odds and you do the evens. So here we do have perpendicular points. However, the perpendicular points are not at the base. So we don't necessarily have a perpendicular bisector. This here with the perpendicular points and equidistant from the line is actually an angle bisector. So it is a bisector, but it is not a perpendicular bisector. So we'll just say B. Let's go to number 3. Number 3, it is perpendicular to the base. It is equidistant to the sides. So yeah, we do have a perpendicular bisector. Let's look at number 5. Find the indicated measure. If we have 14, this is an angle bisector. That means PQ, which is over here, also has to be 14. So PQ is 14. Let's go to number 7. We have a perpendicular bisector. That means the segments have to be equal. So that means to find JG, we have to first solve for x. To do that, we say 4x plus 5 has to equal 2x plus 11. Set it up as an equation. I'm going to subtract 2x from both sides. This gives me 2x plus 5 equals 11. Now I'm going to subtract 5. This gives us 11 minus 5 is 6. So 2x equals 6. Divide by 2. That gives us x equals 3. I'm almost there. I need to take that 3 and I have to put it in GJ, which is this equation. So this has to go there. So GJ is 2 times 3 plus 11, which is 2 times 3 is 6 plus 11 gives us 17. Okay, and that is it for this walkthrough. So all you have to do is finish off the rest for your assignment.